The word bulldozer has nothing to do with bulls, and nothing to do with dozing. In 1876, Louisiana, a bulldozer was a man in a black mask who whipped and murdered black voters to stop them from reaching the polls. 47 years later, 2 Kansas farmers bolted oak planks, a windmill spring, and Model T Ford parts to a Fordson tractor, and backfilled over a mile of pipeline trench in a single day. 10 times faster than horses. They filed patent number 1,522,378. But Caterpillar never built a blade. For 20 years, every Caterpillar bulldozer on every job site in America wore a blade made by 2 small companies that Caterpillar would eventually destroy. By 1943, a Navy Seabee had welded armor plate to his Caterpillar D8, painted the name Helen on the side after his wife, and driven it into a Japanese machine gun nest to earn the Silver Star. This is the story of the first bulldozer blade ever built, because almost everything you think you know about it is wrong. To understand why the bulldozer blade mattered, we need to understand what came before it. And what came before it was blood, horses, and dirt. In 1920, the United States had more than 25 million horses and mules. An estimated 93 million acres of cropland existed for a single purpose: feeding those animals. That was 27% of all harvested acres in the country, dedicated entirely to keeping draft animals alive. The horse was not just the engine of agriculture. It was the engine of construction, and it was eating the country alive. The dominant earth-moving tool of the era was the Fresno scraper, invented by a Scottish immigrant named James Porteous in Fresno, California in 1883. It was a simple, C-shaped metal bowl dragged by 2 to 4 horses across the ground. A skilled operator could load about 4/10 of a cubic yard per scoop and haul it up to 100 feet before dumping. On a good day, that meant roughly 225 cubic yards of dirt moved, 4 times better than a man with a shovel, but still painfully, brutally slow. A Fresno scraper cost between $28 and $37, depending on the model and the number of horses required. For bigger projects, the half-swing railroad steam shovel was the workhorse, a 2.5 cubic yard machine costing $12,000 new. It needed a crew of 10 men. It burned 3 tons of coal per day at $4 per ton, and it could move roughly 1,700 cubic yards in a shift. But steam shovels had one critical limitation. They could only dig and load. They could not push. They could not grade. They could not spread. There was no machine on the planet that could simply shove dirt forward across the ground. Every crawler tractor in existence was a pulling machine. It dragged scrapers and wagons behind it. The idea of pushing something in front had not been commercialized. The human cost of all this was staggering. Construction death rates in the early 1920s ran between 150 and 200 fatalities per 100,000 workers. That was 5 times the average across all industries and 17 times the modern construction death rate. An estimated 30,000 tractor operators were crushed under overturned vehicles in the 50 years before rollover protection became standard. There were no enclosed cabs, no seatbelts, no federal safety regulations of any kind. The Panama Canal, the defining earth-moving project of the era, killed 5,609 workers out of 56,000 during the American construction period from 1904 to 1914. That is a 10% death rate. Men died from train collisions, equipment failures, falls, landslides, and diseases every single day for 10 years. And there was a deeper problem that nobody talked about. The transition from animal power to machine power was happening, but it was incomplete. By the early 1920s, crawler tractors had been around for 2 decades. Benjamin Holt had tested his first tracks in 1904. Caterpillar had formed from the Holt-Best merger in 1925. These machines could pull. They could drag scrapers through dirt. They could tow wagons and chains and stumps. But not a single manufacturer had figured out how to make a tractor push. The entire concept of pushing earth forward, of mounting a tool on the front of a machine instead of dragging it behind, had not been commercialized. Every crawler tractor in America was a backwards-facing tool. Think about what that means. If you needed to fill a ditch, you could not simply push the dirt in. You had to load it into a scraper behind the tractor, drag it to the ditch, dump it, and then go back for more. If you needed to clear a building pad, you had to pull chains across the ground to break up the surface, then scrape the loose material into piles, then load those piles into wagons. Nothing moved forward. Everything moved sideways or backward. The simple act of pushing a pile of dirt from one place to another required multiple machines, multiple passes, and multiple men. This was the world before the bulldozer blade. A world where moving earth meant killing horses and killing men. And a world where the simplest operation we take for granted today, pushing dirt forward, did not exist. But something was about to change. And it started with the biggest political scandal in American history. In 1923, the Sinclair Oil Company was laying a crude oil pipeline across Washington County, Kansas. The pipeline ran from the oil fields of Teapot Dome, Wyoming, to refineries near Freeman, Missouri. This was the same Teapot Dome at the center of the bribery scandal that would send Secretary of the Interior Albert Fall to federal prison. The pipeline trench cut directly across the farm of a 27-year-old named James Dell Cummings, born December 28, 1895, in Morrowville, Kansas, a town of roughly 150 people then and roughly 150 people now. The backfilling method was crude beyond belief. World War I-era trenchers dug the ditches just fine. But filling them back in required teams of horses on one side of the trench and a man standing on the other, dragging wooden boards called slips back and forth until the dirt fell in. This covered from 500 to 700 feet per day. Cummings watched this operation from his farmhouse and walked out to the foreman. He asked if there was a better way. The foreman told him something that changed history. "If you have an idea, we will try it Monday." Cummings recruited his neighbor, John Earl McLeod. McLeod was taking correspondence drafting courses by mail. He could draw plans. Together, they scavenged components from local junkyards and built their device in under 3 days. The blade itself was made of oak planks, reinforced with iron straps, and fitted with a steel cutting edge at the bottom. The lifting mechanism used a spring salvaged from an air motor windmill and a lever cannibalized from a John Deere plow. The frame incorporated parts from a Model T Ford. The entire assembly bolted onto a Fordson tractor with a drawbar pin at the rear and floating brackets on the front axle. Like and subscribe for more construction history like this. On its first day of operation, the contraption backfilled 1 1/6 miles of pipeline trench, roughly 10 times the daily output of the horse teams it replaced. Cummings and McLeod were immediately offered a contract for the entire Sinclair oil pipeline backfill. They had built the first bulldozer blade, and they had no idea what they had created. Now here is where every history of the bulldozer gets something wrong. The patent most commonly cited for this invention is U.S. Patent 1478306. That number appears in dozens of articles, books, and websites. It is incorrect. The actual patent is U.S. Patent 1522378A, titled Attachment for Tractors, filed December 18, 1923, under serial number 681,434. It was granted January 6, 1925. The inventors are listed as John E. McLeod and James D. Cummings, citizens of the United States residing in Washington, Kansas. The patent was never assigned to any company. It remained with the two men personally. The patent text reveals how modestly they conceived their invention. They described it as an attachment for tractors by which the surface of the ground may be easily brought into a level condition, intended more particularly for filling ditches in which pipelines have been laid. They saw it as a ditch filler, not an earth mover, not a weapon of war, not the foundation of a $60 billion industry, just a better way to fill a trench. The technical design described push bars extending forward below the tractor, a scraper board of stout planks at the front, a rock shaft mounted on the front axle for vertical adjustment, and a hand lever at the rear, allowing the operator to raise and lower the blade while driving. The entire mechanism depended on manual force. No hydraulics, no cables, just a man pulling a lever connected through a pitman rod and rocking arm to a wooden blade. What happened next between the two inventors is a story of quiet tragedy. Cummings and McLeod worked together in the pipeline business for about 2.5 years. Then McLeod's wife died. She left him alone with 2 young children to raise. He needed money. He needed stability. So he sold his entire share of the partnership and the patent to Cummings for $500. Cummings went on to become what the industry called Mr. Pipeliner. He eventually held 68 patents for pipeline construction equipment. He co-founded Crutcher Rolfs Cummings Incorporated in Houston, a firm that built oil pipelines across the world during World War II. On October 12, 1964, he received the Presidential E Award for Excellence from the Department of Defense. Some credited him with making it possible for the United States to win the war. He died wealthy in San Marcos, Texas, on May 27, 1981, running a showplace automated cattle farm. McLeod vanished. For 62 years, his contribution to one of the most important inventions in construction history went unrecognized. It was not until June 1985 that a local resident named Dwayne Durst organized a celebration in Morrowville, where a hand-built replica of the original Bulldozer was unveiled. McLeod attended as an honored guest. He was an old man by then. Durst told reporters he wanted to recognize the man whose work had been hidden in history. Today, a replica of the first Bulldozer blade sits in Cummings Park on Oak Street in Morrowville, Kansas, 2 blocks west of Highway 15. The park is named after Cummings, not McLeod. But here is what makes this story more complicated than just 2 farmers and a patent. While Cummings and McLeod were filling pipeline trenches in Kansas, someone else was putting a blade on a crawler tractor. That distinction matters. The LaPlant-Choate Manufacturing Company of Cedar Rapids, Iowa, is generally credited with producing the first commercially manufactured bulldozer blade fitted to a track-laying crawler tractor. The company had roots going back to 1889, when E.W. LaPlant began his career moving houses and pulling tree stumps in Marshalltown, Iowa. His nephew, Roy Choate, joined the business in 1911. By 1920, LaPlant-Choate had reportedly tested a dozer blade on a crawler at the City of South Milwaukee garbage dump. By 1923, their blade was used on the Dixie Highway in Kentucky. By 1924, they were manufacturing a hand-crank blade for the Holt T35 tractor. The critical distinction is this. Cummings and McLeod mounted their blade on a wheeled Fordson farm tractor. LaPlant-Choate fitted their blades to track-laying crawlers. The crawler configuration is what became the modern bulldozer. A blade on a wheeled tractor could fill ditches on flat Kansas farmland. A blade on a crawler could climb hills, cross mud, push through stumps, and reshape terrain. That was the configuration that changed construction forever. The early blades were controlled entirely by hand. The operator sat on an open platform with no cab, no roof, and no protection of any kind. To raise or lower the blade, the operator turned a hand-crank worm gear against thousands of pounds of soil resistance. Hundreds of cranks per shift. The gears had no guards. If your hand slipped, the crank handle could spin backwards and break your wrist or your fingers. Operators called them knuckle busters for a reason. And the blade itself was a crude instrument. Early models used a fixed mounting that could only move straight up and down. There was no angle adjustment, no tilt. If the operator needed to push dirt to the left, he turned the entire tractor to the left. If the ground was uneven, the blade dug in on one side and rode up on the other, and the operator had to compensate by constantly adjusting his steering. Every pass across a job site was a fight between the machine and the ground, with the operator caught in the middle, using nothing but his hands and his instincts. The physical toll was enormous. A 10-hour shift on an early bulldozer meant turning a hand crank against resistance for most of those 10 hours. Operators developed forearms like blacksmiths and chronic joint problems that lasted the rest of their lives. The vibration from the crawler tracks traveled straight through the frame and into the operator's spine. There was no suspension, no cushioned seat, just a metal platform bolted to a shaking machine. Studies done decades later found that whole-body vibration on these machines increased the risk of back injury by 4 times compared to the general population. Then, in 1928, a 6th-grade dropout named R.G. LeTourneau changed everything. LeTourneau invented the power control unit. It was an enclosed cable winch driven from the tractor's power takeoff that could raise and lower the blade mechanically instead of by hand. One lever replaced hundreds of hand cranks. The power control unit became the industry standard almost overnight. But LeTourneau's cables created new dangers. Steel cables under 12,000 pounds of tension could snap without warning. When they did, the broken end whipped through the open cab at over 100 miles per hour. There was nothing between the operator and the cable. No shield, no cage, no protection. Cable snap was the single deadliest hazard of the pre-hydraulic era. An estimated 2,400 bulldozer operators died from cable-related accidents between 1940 and 1955 alone. Meanwhile, LaPlant-Choate went a different direction. They pioneered hydraulic blade controls while LeTourneau dominated cable systems. The two technologies ran in parallel for decades. A typical World War II D7 bulldozer might pair a LaPlant-Choate blade with a LeTourneau power control unit, because LaPlant-Choate never built its own cable winch system. The competitors were also collaborators. Even as they fought for market share, their products often ended up on the same machine. Like and subscribe if you are enjoying this deep dive into construction history. Now we need to talk about Caterpillar. The company most associated with bulldozers in the public imagination played a very specific and very calculated role in this story. Caterpillar Tractor Company, formed in 1925 from the merger of Holt and C.L. Best, deliberately chose not to manufacture its own blades for nearly 20 years. Instead, it relied on preferred suppliers, primarily LeTourneau and LaPlant-Choate. Their blades and attachments were sold through Caterpillar's worldwide dealer network as if they were Caterpillar products. They were not. By the 1930s, 92% of all track-type tractors on the largest construction jobs in America were Caterpillar machines. Every single one of them wore a blade made by someone else. The strategy was calculated. Caterpillar focused on building the best tractor in the world and let the attachment companies handle the rest. It was efficient, it was profitable, and it gave Caterpillar enormous leverage over its suppliers, because those companies depended entirely on Caterpillar's dealer network to reach their customers. In 1944, Caterpillar pulled the plug. The company severed its preferred supplier relationships with both LaPlant-Choate and LeTourneau and began manufacturing its own attachments. The timing was deliberate. The war had created massive demand for bulldozer blades. and Caterpillar had watched its suppliers grow wealthy on products that were sold through Caterpillar's own dealer network. The company decided it wanted that revenue for itself. The move was devastating. LaPlant-Choate, stripped of Caterpillar's distribution network overnight, had no way to reach the thousands of contractors who had bought their blades through cat dealers. The company struggled financially for 8 years, trying to build its own sales channels while competing against the very dealer network that had once sold its products. It was a losing fight. In September 1952, Allis-Chalmers swallowed LaPlant-Choate whole. The entire company, patents, trademarks, tooling, factory equipment, everything, was repainted in Allis-Chalmers Persian orange and absorbed. The name LaPlant-Choate, the company that had put the first commercial blade on a crawler tractor, disappeared from the construction industry forever. LeTourneau saw the writing on the wall earlier. He pivoted aggressively away from earth-moving attachments. He sold his entire earth-moving line to Westinghouse Airbrake in 1953 for $31 million and redirected his considerable energy into offshore jack-up oil platforms, experimental military vehicles, and ambitious attempts to build Protestant capitalist utopias in the Peruvian Amazon. He called his workers in Peru technical missionaries who could handle a bulldozer as well as a Bible. The Reverend Billy Graham personally blessed a shipment of his equipment, leaving Vicksburg for West Africa in 1952. Locals called the vessel the Ark of LeTourneau. The rivalry between the two supplier companies had been real. LaPlant-Choate had even named its towed scrapers Carrimors as a deliberate mockery of LeTourneau's famous Carryalls. But in the end, it did not matter who was cleverer or who had better products. When Caterpillar decided to make its own blades, both companies were finished. Now we need to go back before the machine, back to the word itself, because the origin of the name bulldozer is one of the most disturbing and least known facts in the history of construction equipment. The word bulldozer first appeared in print in November 1876 in Louisiana newspapers, nearly 50 years before the machine existed. It had nothing to do with construction. A bulldozer in 1876 was a member of a white supremacist vigilante group that beat, whipped, and murdered black men to prevent them from voting Republican in the contested presidential election between Rutherford B. Hayes and Samuel Tilden. Like and subscribe so we can keep bringing you these deep dives. The etymology is grim. One theory holds that bulldoze meant a dose fit for a bull, a beating so severe it would stagger an animal. The other traces it to bull as shorthand for bullwhip, the braided lash used on cattle and on enslaved people. The vigilantes wore black masks or face paint and operated at night. One Louisiana newspaper from 1876 reported that bulldozers took a black Republican voter from his bed and hanged him from a tree 2 miles from his home. The semantic journey from there is one of the strangest in the English language. From racist vigilante in 1876 to a type of firearm in 1877, to a blacksmith's metal bending press in the 1880s, to an ice-breaking device on canal boats around 1910, to mule-powered earth-moving blades in 1917, to the tractor-mounted blade in 1923, and finally, to the entire machine by around 1930. The World War II Seabees are largely responsible for making bulldozer a household word. Before the war, most Americans had never heard the term applied to construction equipment. And it was in that war that the bulldozer blade became something its inventors never imagined: a weapon. Colonel K.S. Anderson of the United States Army Corps of Engineers wrote in 1944 that of all the weapons of war, the bulldozer stands first. Airplanes and tanks may appeal more to the public imagination, but the Army's advance depends on the unromantic, unsung hero who drives the Caterpillar. LeTourneau's factories produced 70% of all earth-moving equipment used by the Allied forces. 14,000 bulldozer blades, 10,000 carryalls, 1,800 tornapulls. His machines built the Pacific airfields, the Alaska Highway, and every post-war suburb from Levittown to Los Angeles. The first recorded combat kill by bulldozer happened on October 27, 1943, on Mono Island in the Treasury Islands chain. Machinist's mate 2nd Class Aurelio Tassone of the 87th Naval Construction Battalion drove his 24-ton Caterpillar D8 toward a Japanese pillbox that had pinned down the 8th New Zealand Brigade. He had named the machine Helen after his wife. He raised the blade as a shield. Lieutenant Charles Turnbull provided covering fire with his carbine. Tassone advanced under heavy fire, lowered the blade, and crushed the pillbox. All 12 Japanese soldiers inside were killed. Both men received the Silver Star. Tassone became a literal Seabee poster boy. His image was used in recruitment materials across the country. What made Tassone's attack possible was not just courage, it was the blade itself. The raised bulldozer blade acted as improvised armor, deflecting small arms fire and shrapnel that would have killed the exposed operator. Japanese defenders had no weapon light enough to aim quickly and heavy enough to penetrate the curved steel plate of a D8 blade at close range. After Tassone's attack, Seabee units across the Pacific began welding additional armor plate to their blades and cabs as a standard field modification. Some units stripped armor from knocked-out Japanese tanks and bolted it directly to their bulldozers. The construction machine was becoming a combat vehicle through sheer improvisation. Seabee ingenuity with bulldozers became legendary in the Pacific theater. When a dozer broke down and parts were unavailable, they replaced blown head gaskets with thin sheets of metal and paper. They fashioned replacement radiators from fuel drums and ammunition boxes. They built condensers from waxed paper, tinfoil salvaged from cigarette packages, and old beer cans. When a machine was too damaged to repair, they sometimes simply bulldozed the broken dozer into the ocean and started a fresh one from the supply ship. The speed of Seabee construction was staggering. On Vangunu Island in June 1943, Marines landed at 10:30 in the morning. By 3 in the afternoon, Seabees had begun building a fighter airstrip with their bulldozers. 9 days later, the first plane landed. On Tinian Island in 1944, Seabees built 6 runways, each long enough for B-29 bombers, in under 5 months. The atomic bomb missions against Hiroshima and Nagasaki launched from airstrips that Seabee bulldozers had carved out of Pacific coral. Armored bulldozers were also among Hobart's funnies, the specialized vehicles developed for the D-Day invasion under Major General Percy Hobart. Their job was to clear beach obstacles, fill bomb craters, and open roads through rubble. The Americans at Omaha Beach declined most of Hobart's specialized vehicles, except for swimming tanks. Many historians believe this decision contributed to the catastrophically higher casualties there. By the end of the war, no fewer than 7,000 funnies had been manufactured. The bulldozer blade's military career did not end with World War II. In Vietnam, the Rome Plow, a razor-sharp stinger blade weighing over 2 tons and manufactured in Rome, Georgia, was mounted to Caterpillar D7E bulldozers to clear triple canopy jungle. Operators called them hogjaws and jungle eaters. The 60th Land Clearing Company and similar units cleared 750,000 acres of Vietnamese jungle to deny cover to the Viet Cong. The Rome Plow blade had a reinforced leading edge and a curved stinger tooth that could split a hardwood tree 3 feet in diameter. Operators worked in formation, 5 or 6 machines abreast, pushing through jungle at walking pace while infantry guarded their flanks against ambush. It was dangerous work. Viet Cong fighters targeted the lead bulldozer because stopping it stopped the entire column. And during Operation Desert Storm in February 1991, 3 brigades of the 1st Mechanized Infantry Division used bulldozer-equipped M9 armored combat earth movers and Bradley fighting vehicles fitted with mine plows to execute what became known as the Bulldozer Assault. Over 2 days, they plowed over 70 miles of Iraqi front-line trenches, burying unknown numbers of defenders alive in the sand. One colonel later said that for all he knew, they could have killed thousands. What you saw was a bunch of buried trenches with arms and things sticking out of them. Reporters were banned from witnessing the assault. The Pentagon initially denied it had happened at all. When journalists broke the story months later, the Army confirmed the operation, but insisted it was a legitimate tactical maneuver, not a war crime. The debate has never been fully resolved. Like and subscribe for more construction. Street documentaries every week. All of this, every mile of highway, every Pacific airstrip, every dam and foundation and building pad on Earth, traces back to a single moment. 2 men on a Kansas farm in 1923, staring at a pipeline trench and a crew of horses that could only fill 500 feet per day. James Cummings went on to build pipelines around the world and earn a presidential award. John Earl McLeod sold his share for $500 and disappeared for 6 decades. The patent that every history cites is wrong. The company most associated with bulldozers refused to make its own blade for 20 years, and then it destroyed the companies that had been making them. And the name of the machine itself carries a century of violence in its syllables, from Louisiana voter suppression to Pacific Island combat, to Vietnamese jungle clearing to Iraqi trenches in the desert. A replica of the first bulldozer blade sits today in Cummings Park in Morrowville, Kansas. Population 150, oak planks, iron straps, a windmill spring, a John Deere lever, Model T Ford parts, and a Fordson tractor that could fill a mile of ditch in a day. That was enough to reshape the planet. If you want to see more from the Before Hydraulics series, the full playlist is on screen now. And if you want to know what happened when Caterpillar killed the steam engine with a different invention in 1931, that video is waiting for you right there.